Good morning, class. How you guys doing today? So we're going to get a little bit deeper into inverse functions. Inverse functions that we talked about yesterday. So inverse functions. One more time. So yesterday we saw that you can figure out what the inverse of a function is, or that the inverse is something that undoes or does the reverse or the opposite of what an initial function did. And just to recap, if a function was x plus 2, then its inverse would be x minus 2. Let's think about it in terms of domain and range. If I have my domain here, remember domain is the x values, and I have my range here, and remember range is the y values. If some unknown function takes the number 2 and it takes it from 2 to, according to this function, let's say I'm using this function, it will take it from 2 to 4, right? It will take the number 3 to 5, it will take the number 8 to 10, and so on and so on. Take the number -6 to positive, no, just kidding, -4. So this function takes a number from the domain, and then that number takes it to a certain number in the range. The inverse function is what does the opposite. The inverse function is a function that would take -4, take it back to 6, to -6. Use another color. The inverse function would take -4 back to -6. It would take 10 back to 8. That's the inverse function. It undoes what the original function did. It would take 4 back to 2. So if these were if I try to write the coordinate points of the function fx equals x plus 2, the coordinate points for that function would be 2, 4, right? Just seeing from back here. 2 goes to 4, 3 goes to 5, 3 goes to 5, 8 goes to 10, -6 goes to -4. Do I have any others? Nope. Okay, and if I had any other points, if I had like a 10, I would go to 12. Those are the coordinate points of the function fx. However, if I try to write the coordinate points of the function inverse of x, if I try to write the coordinate points of the inverse function, because remember the inverse function is x minus 2, I write by starting with input, which is x, and then output, which is y. For the inverse function, if I put in 12, what would it give me? It would give me 10. So the coordinate points would be 12, 10, right, for the inverse function. And then -4, -6, and then 10, 8, and then 5, 3, and then 4, 2, because I know that the inverse function is going to get this input and take it to that output. That's the inverse function. It's going to take the input, take it to that output. And if you look at it critically, it's just typically as if you have just flipped the x and y. This was 2, 4, and it's now 4, 2. I've just flipped the x and y. The x has taken the position of the y. This was 3, 5, and now it's 5, 3. So inverse function basically just flips the coordinate points. So if I was given a coordinate point like 3, 12, and I'm not even given a function equation, but I'm asked to write the inverse of this coordinate point, its inverse would just be 12, 3, because I know that whatever the inverse function is, it will flip the coordinate points. The normal function would take the input and make that into the out. Like it would take the input, it would take 3 and then spit out 12 or give you 12. The inverse function should be able to take 12 and give you back your 3. So that's, you just simply flip them around if you're trying to get the inverse of coordinate points. This can be useful in an instance if we have, say, a table of x and y, or x and fx. If I have a table of 2, 3, can be random things that don't even seem to have any relation, or normal things that have a relation. If I have this table, it can be as long as I want, and then I'm asked for something like, what is the f of -1? Well, I can look at my at my table, and I see that for this function, if the input, because x is always the input, if the input is -1, my output is 0. So f of -1 is going to be equal to 0. Well, what is the f inverse of 11? Again, if I'm looking at the inverse function, then I know that my input 11 is supposed to be the output of the function if I had put in 10 in the normal function, just as we were looking at on the previous page. So if I'm looking for the inverse function of 11, I'll just come here, look for 11, its inverse function. This function takes 11 back to 10. Its inverse function is 10. Or I could have just written the coordinate point, and I know this is the normal function, so the inverse function will be 11, 10. So that means the inverse function takes 11 back to 10. That's what that simply means. Okay, so still yesterday we looked at how to find inverse functions. You can have some interesting function like this, x plus 2 over 3 and it's squared and minus 8, and you want to find the inverse. If you look at it, don't let it scare you. Remember, the inverse undoes what this function initially did. So if I'm going to undo what this function is doing, I'm going to do that in order. First of all, I'll start with what this thing did last. That was to subtract 8. So the first thing I'm going to do is to add 8. Next thing this function did is it squared. So the next thing I'm going to do is take a square root of this term. After that, this thing divided whatever, this component was divided by 3. So the next thing I'm going to do is multiply this whole thing by 3. I'm going to multiply by 3. I can either put it there or there. Next thing this thing did is it added 2, so I'm going to subtract 2. So that's my inverse function. Remember, I told you it's just as if you are making x the subject of this thing. That's kind of the process. A simpler way to look at it, or like a more religious way, would be I can say, let me just say y is equal to x plus 2 out of 3 squared minus 8, and then I try to make the x the subject. If I try to make x the subject, first thing, take away the 8, so I have y plus 8. Next thing, I have y plus 8 equals x plus 2 over 3 all squared. Next thing I need to take away is the squared symbol. Do that by taking the square root. X plus 2 over 3, and then I would have to multiply both sides by 3 to get rid of the 3. So I have 3y plus 8 square root is equal to x plus 2, and then finally I would have to subtract the 2. So that's 3y plus 8 square root minus 2 equals x. And when I have it in that form, I can 3y plus 8 square root minus 2, and I want to write the inverse function. I would just replace the y with x. This is like a more hands-on approach. You don't have to do it like this. I'm just showing you an alternative. Okay, today one thing that's is going to be let me end this one and make another one.